is data visualization with D3.js. My name is Clinkinbeard. Hopefully this is the presentation you meant to be in. I do apologize for the browser Chrome being up there. I was planning on doing it full screen, but realized sort of late in the game that some of my demos don't work in full screen mode for whatever reason. A little bit about myself. I'm a principal architect at Universal Mind. That's what the tab on the side is. It's just the logo of the company. I had a couple of questions about whether that's like a menu or anything. It's just the slide design. For the last about 5 years, I've been working for Universal Mind almost for 5 years, primarily doing Flex work. Prior to that was doing a lot of Flash work, a little bit of random server-side stuff, but primarily client-side. If anybody is a Flex developer or former Flex developer, depending on how you look at it, I was one of the leads of the Swizz framework for Flex, and prior to that, the Flex MDI library, which was, I believe, all the way back in the Flex 2 days. And for about the last 3 years, I've been working on basically the same project at UM, doing a lot of data visualization with the Flare library. Has anybody in here done any data visualization work? 1, 1.5, 2.5, something like that? Okay, a few. Have any of you used the Flare library? No? Okay, Flex charting? No? What did you guys use? Okay. Okay, so you're familiar with charting in JavaScript. Good deal. So D3's background info, just sort of a little, basic rundown. It is open source with a BSD license. That's entirely permissive. You can do whatever you want with it. Use it for whatever you want. D3.js.org is the site, hosted on GitHub like any good project. The primary author behind it is a guy named Mike Bostock. I think that's Bostock, something like that. He is the primary driver behind it, but especially lately, he's had some people coming in and contributing specifically like mapping and geographic sort of algorithms and just all kinds of crazy sort of intellectual things that I don't understand, which sort of leads into the academic pedigree of D3.js. So D3 kind of came from, is sort of the latest in a line of a few libraries. There was the Prefuse library for Java, which eventually the same guy moved on to the Flare library, which was ActionScript 3. It wasn't really aimed at Flex per se. It was just sort of straight up Flash. I believe, is anybody familiar with the Gapminder visualization? Sort of a really well-known data visualization that I believe is like 6 years old now. I'm pretty sure that was written in Flare. It was eventually acquired by Google. And then the same guys kind of moved on to ProtoViz, which was a JavaScript library. The main author behind Prefuse and Flare was a guy named Jeff Here, and then I believe him and Mike Bostock moved on to ProtoViz together, and then Mike has sort of gone on with D3. The academic pedigree that I mentioned, Jeff Here was actually Mike Bostock's PhD advisor at Stanford, where I think Jeff Here, he's now a professor at Stanford doing a lot of data visualization work, sort of like, I don't know, what I call real data visualization work, where they really study the science behind, how to design the layouts, what the real algorithms are behind it. And again, stuff that's just way over my head. So all that's great. It's very heady, very well-grounded in, applied statistics and other various things, but is it cool? And I'm kind of tethered to my laptop here, unfortunately, since I'm using this browser-based thing. I don't have like a cool little clicker on my phone, but I figure since it seems like nobody has a whole lot of experience with D3, I'd start off with a couple of cool demos that I did not write, just to kind of show you what it is we're talking about here. So the D3 website, if you haven't been, highly recommend going and checking it out. They've got a massive wall of just various demos that you can check out and sort of get an idea for the power that that the library has, which is very impressive. So this is what they call a stream graph. I'm not entirely sure what kind of data you would use this to show, but just to sort of show the performance that you can get out of this. This is using SVG, which we'll go into a little bit more, but you know, the performance, I believe there's 30 different streams there that are, and I just have it sort of cycling through random data sets, but you can see very smooth animation. This one is completely meaningless, but again, just to sort of show, you know, the performance, which this was actually adapted. Mike Bostock adapted this from a demo that he had seen in some other library that I cannot remember for the life of me now, but sort of just wanted to recreate it. And then this one, this is my favorite one, just a basic collision detection demo that sort of, they, you know, avoid your mouse. There are 300 circles on there, runs completely smoothly, and this is about 70 lines of JavaScript. So, I mean, they've designed the API in such a great way that, you know, you really just kind of need to know which pieces to pull out of the library, and you can come up with something pretty amazing. Again, not terribly useful, not something you would probably put in an application, but you know, definitely shows off the performance and power. So D3 is called D3 because it stands for data-driven documents. And that's something that it's kind of good to keep in your head, because when you're implementing these, you really want to focus on, you know, making sure your data is right, and then you sort of just pick and choose from the API, and D3 handles the actual, you know, DOM manipulation based on your data. So, like I said before, the demos that I just showed were using SVG. You can create visualizations without SVG, but then you're basically limited to, like, you know, divs and spans and things like that. So for the interesting, good stuff, you're going to end up using SVG. Obviously, HTML and CSS are involved. That actually becomes more powerful than you might think, because, and I'll show some of this later, but as you go through and you're developing, you can actually use, you know, the web inspector to go in and actually select a circle that's on your chart and inspect it and change the CSS class and, you know, sort of do like a poor man's live edit of your visualization while you're tweaking things. Be warned, SVG means IE9 is your lowest common denominator for, you know, baseline support. Microsoft didn't really get their act together with SVG until after IE8. So if you have to support IE8 or 7, this is out. There's a charting library called Raphael.js, which I don't know the details on it as far as how exactly it's implemented, but I do know that there is some sort of plugin that you can use basically to sort of bridge your D3 into a Raphael.js that sort of gets over some of those compatibility issues. But I recently saw somebody saying that the D3 to Raphael bridge will make your visualization work on IE 8 in like Windows XP, but not Windows 7. So don't rely on that either. So very, very basic introduction to SVG. You basically have these 6 elements to choose from. You got a rectangle, circle, ellipse, line, text, and path. Line is just, X and Y to X and Y. Path is for the more involved, curves and Beziers and all that fun stuff. Text, you may come across some demos that are using SVG text elements. Unless it's a very, very basic small need, I wouldn't recommend it. You don't get things like it doesn't really take into account the dimensions of the text, so things are very easily cut off, and you're better off kind of just combining a regular, DOM span element if you need text. Super 2 bullet point SVG basics. You have to have an SVG root tag, and the element declaration determines the depth. So you declare one thing. So here's our base SVG tag. Give it a width and a height. 2 circles. The second circle that's defined there is going to be rendered over top of the first one. You don't have any sort of native to SVG depth management. There's no Z property. So the only way that you can manage depth is, actual DOM manipulation, remove element, insert it behind this one sort of thing. So that's my sort of base introductions. How do we actually do this stuff? And hopefully you'll agree with me that it's actually incredibly easy for what it allows you to do. We're going to build a basic bar chart. The very first one we'll do without SVG, just to sort of show you that it's possible. And then we'll kind of move on to a little more interesting stuff. Obviously, you need a data set. For basically all the examples that I'm going to show, we're going to use this very simple data set, 5, 10, 15, 20, 25. So the first thing you need to do is tell D3 sort of what context you want to build your visualization in, right? In this case, we want D3 to select the body, and we're just going to fill the entire document with our visualization. The select method basically just uses CSS3 selectors, so you can select by ID, by element type, by CSS class, whatever the case may be. Then you're going to say, okay, within that body, I want you to select all the divs. My data is this data set. So I might be talking ahead of myself a little bit here, but sort of these 3 lines is sort of where D3 starts. This is where the magic starts to happen. So you've told it to select all the divs in your body, and you want it to merge this data set into it. And essentially what it's going to do is merge those selections. And I'll come back to that. It's going to be a little more clear in a second. So once you've selected all the divs in the body, if there are more data points than divs in the body, you're going to end up needing to use what they call the enter selection. So if we've got 5 data points, but it only finds, let's say, 3 divs in the body, it's going to create 2 placeholder divs for those data points that it didn't have a corresponding div. And you can act on those elements by using the enter selection. Everything past the enter selection is going to operate once for every data point that it needs to add in. So we've now got sort of a looping reference to our data points and their corresponding elements. And we're going to tell it to append a div. So it's merged these. It knows there's not as many elements as data points. So each time it comes to one of these placeholders, we want it to actually append a div element for us. we're going to set an attribute, which is the class name, just to bar. And then we're going to set an actual style property. And for that style property, we want it to accept the data point, the D argument, multiply it by 5, and return that number plus px for pixels. And then just our CSS class, just a normal CSS class. As you can see there, the height element is actually going to be overridden by that .style call that we have. So it'll sort of override that when it actually renders. And what amazing visualization does this give us? Ta-da, that's it. So again, not exactly cool, but that's sort of almost the extent of what you can do without relying on SVG. So here's the thing, going back to the merging and the data, the merging of the elements, this is actually the body tag that we started off with. So we told it to select all the divs in the body, but there are none. And this is sort of something that's, at least it took me a little while to get my head around, that you sort of have to get used to with D3, that it may not have everything it needs when you start, but it's going to create those placeholders for you and then let you sort of act on them as it comes in. So the way they describe it is, instead of telling D3 how you want to do, or how to do something, tell it what you want. So you're never going to bust out like a for loop and tell it, okay, add a div inside this for loop, do this inside this loop. You're just going to say, I want you to select all the divs in the body. If they're not there, just create one for me. So selections, which is kind of what what I started to touch on there. Selections are a very core concept of D3. So when you say select the body, select all the divs, grab this, put this data in there, you've created a selection. So that selection is the divs that correspond to that data. It joins the selection to the data, and I did talk ahead a minute ago. Everything beyond that data call is going to be executed for each data point in the call, or in the data set. Sorry. I've got in these slides. I haven't posted the final version. I did some tweaks that aren't pushed yet, but these will be on my site. So I've got a link here to the selections wiki, which is highly recommended reading if you're going to do D3 work. So the selections API, once you get a selection of these elements, you basically have 5 methods that you can call on a selection. And again, D3 is going to call these on each data point and element pairing in your set. So you can set an attribute, which just, you've got the attribute method, which is going to just, like it sounds, going to set whatever the attribute name is, just like you would do in HTML. If you pass a value, it's going to set that attribute. If you don't pass a value, it'll just return you the value of that attribute name. Style is just what it sounds like. It's just like if you set a style attribute in your HTML and then did actual styles in there. Same thing. If you pass a value, it'll set it. If you don't, it'll return it. Property is for things like the checked property of a checkbox or selected or various things that aren't sort of your traditional attribute value pairing. HTML, you can just plain old set the HTML contents if you want. It basically maps to the inner HTML function on a DOM element, and then text is, again, just text. If you were, I've seen some basic D3 demos where they're basically creating paragraph tags, and you can just set the text to whatever value it is you want. So just a couple of examples, and then sort of another core concept to be aware of. Using the attribute method here, we've selected the body, selected all the divs. We want it to set the CSS class of bar on all of those divs. In that case, we're just passing in a value, right? We want it to be the bar class. In the bottom example, we're actually defining a function. So if you don't want to set a static predetermined value for everything, and you want to be able to run some logic, you just pass in a function instead of a value. And D3 is smart enough to know how to call that. D is the datum being rendered, so the individual data point that maps to that element. I is the index in the data set. And we'll see some of this later. And then obviously you return whatever value you want based on any logic that you've run. But this sort of pattern is good to get in your head because basically you can do this anywhere. Anywhere that you can pass a value into D3, you can pass in a function, more or less, and it knows how to call it. Yeah. Well, if you had already created your visualization here, you wouldn't have to. You only have to pass the data in once, right? So, but that's a good question. He asked if you had to call the data method before you start doing this sort of thing. And if you haven't populated your chart yet, you would. But in this case, we're assuming that it's already in there. But so you can just, ingrain this sort of function signature into your head that you can always pass in a function rather than a value, and that function is always going to receive the data and the index in the data set. And obviously, if you don't care about the index, don't put the I argument on there, and you'll be good to go. So it's sort of just showing that again, the consistency of the API. Same thing for the style method. You can either pass a value in or a function. It's going to give you the same thing. And then again, just talking about showing what I talked about before, where if you call these methods and don't pass in a second argument, it's actually going to basically turn it into a getter and let you retrieve those values. So we can pull out the class name by calling attribute class with no second argument. We can pull out the background color style value by calling style without a second argument. So enter and exit. I sort of struggled a little bit about how much I wanted to get into this concept in this talk because I wasn't sure how much time I would have, and it's a little bit, it takes a little while to get your head around, or at least it did for me. So the enter and exit are subselections representing elements to be added or removed. So, I kind of mentioned before, if your data set has more data points in it than elements are on there, the enter subselection is going to represent those placeholder elements that have not yet been created. So you're going to end up calling append and tell it, okay, for all these placeholders that you created, I want you to actually add an element to the DOM. You can also use, I believe it's insert, if you need to insert the DOM element at a specific position, but generally you're just going to use append. Exit is sort of the opposite. So if your data set changes and there are DOM elements that no longer have a corresponding data point, those DOM elements are now in the exit selection, and you're eventually going to want to call remove, right? Because they're no longer in the data, so you need to remove the existing DOM element. And the reason I say eventually is because you're probably going to want to fade them out, animate them off, do some sort of transition other than just having them disappear. So scales. Scales, to quote Mike Bostock, scales are functions that map from an input domain to an output range. And so anybody that's done data visualization before probably is well aware that one of the challenges, especially in a lot of libraries, the flex charts come to mind, that it can be very difficult to sort of map from screen dimensions, X, Y, pixel dimensions, to sort of data dimensions, right? Because you may be plotting data that runs from a value of 0 to 5,000, but your visualization is 600 pixels wide. So you have to have some sort of way to sort of map between those. And that's what scales in D3 do. They sort of map from one domain to another. And my last point there is that they make your charts infinitely more flexible. It's entirely possible to write a D3 visualization without using scales and just sort of manually, manually say, plot this one 30 pixels from the edge of the chart area, but that's going to be a nightmare. So this is sort of the first. Can people in the back read the text on these? Okay. This is sort of our first top-to-bottom SVG-based example. So we've got the same data set that we had before. We've got a width and a height variables set up, W and H, and we're going to tell D3, select the body, append an SVG tag. Again, that's the base SVG that you need to dump everything into. Set the SVG's tag, set its width and height attributes to the width and height that we've defined above, and then just give it a pretty gray background. Now that we've got the SVG element in our SVG variable, we can say, okay, SVG element, select all of the circles inside of you. Obviously, there are no circles inside of there because we just created it. But we're going to tell it to merge in this data set. At that point, it's going to create 5 placeholder circle elements that are going to then be part of the enter selection because they don't exist yet. And so for each one of those, as it runs, so basically, like I said before, everything after the data call or maybe the enter call is going to be run 5 times because we have five data points. So for each one of those, I want you to append a circle. I want you to set its opacity to 0.3. I want you to set its CX and CY, which is just the X and Y coordinates for an SVG circle, which it's because it's based on the center of the circle, so center X, center Y. Just return the data point and set the radius, or the R attribute, to 12. And what magnificent visualization do we get from that? We get this lovely thing, which is probably kind of hard to tell there, but we've got 5 overlapping circles. They're plotted at 5 pixels X and Y, 10 pixels X and Y, so on and so forth. That's not really that helpful because they're pretty small, or pretty crowded together. So if we want to add an X scale, instead of simply returning the data element for the CX property, we're going to create a scale. And as you can see, this is just a built-in D3 object where we say d3.scale.linear. So, and that's just a linear mapping from data space to coordinate space. And the only reason I mention that D3 has, again, all kinds of academic sort of things that I don't understand, like logarithmic scales and other stuff that's above my head and out of the scope of this presentation. But once you create that scale, so we've created a linear scale, we're calling its domain method, that's your domain, your data domain. So we want the minimum value of that scale to be the minimum value in our data set, again, using handy D3 method there. And we want the maximum value to be the maximum value in our data set. So it's going to map from 5 to 25, right? That's our data range. And the range call on the scale is then your pixel space. So we want the minimum x value to be 0 and the maximum x value to be the width that we've defined for our chart. And then instead of just returning the data element in the CX function, we're going to return the data element passed through that x scale that we just created. And what does that give us? We've got a stretched out scale now. We've actually managed to make a reasonable width of items on our scale. At a Y scale, same exact concept. You're just obviously, instead of basing it on the width of the scale, you want to base it on the height and then pass the value through the Y scale when you're setting the CY property. So that gives us this. So we're making progress, right? It's a little better than everything scrunched up in the corner. We're using the entire space available to us. But here's where the flexibility comes in. You want to change the size of your chart. The only thing you have to change is the width and the height that you've defined for it, because it's going to map your data scale to your pixel scale. And just by changing the width and the height, you've changed the dimensions of your actual output. So as you can see, that's a lot better than every time you decide, actually, I want this chart to be a different size, having to go back and manually recalculate things. Obviously, it's not good for things to run off the side of your chart, so you can simply add in a padding variable. That's something you'll usually just define at the top with your width and your height, and then you use the padding as sort of the minimum x, and the width minus the padding as the maximum, and that'll prevent your runoff. So scumbag SVG always orients top left, so Y values go from top to bottom, right? But at least me, based on every X and Y chart I've seen since 7th grade math, I would expect those values to be mapped from bottom left to upper right, right? Y goes from here up. Well, again, scales to the rescue. If you simply reverse the range argument that you've sent to your scale and say, instead of the minimum value being my padding, I want the minimum value to be the height minus the padding and the maximum to be the padding, it basically just flips that and you get that actual output like you would expect. Scales also normalize your data. So in this case, we've added a data point that is at 100, and it has automatically adjusted the scales in the pixel space so that, since we're basing the scale off of our data set, 100 is now the maximum value. 25 is no longer mapping all the way to the side, or the bottom, or the top, whatever. This is where things get really cool. And this is something that I discovered basically during my research for this talk. You can use scales for anything because D3 is badass. So just create a color scale. The first part is exactly the same, d3.scale.linear. Domain is still our data set. I just manually put the data points in here. And the range is now orange and purple. And it's smart enough to just know how to interpolate those values. So now you say fill, run the value through my color scale, and it's going to color them for you. Yeah?
Where would that add or fill? Would that be in the header section?
Yes.
Okay.
So I don't know about you, but I thought that was pretty damn awesome. You can also do, multi-step. So I've changed the domain to be sort of the minimum, the middle, and the maximum value, given the range 3 colors, and it'll actually still do the same thing. So the colors are obviously not extremely accurate on this screen, but our minimum value is absolute red, middle is absolute purple, top maximum is absolute green. Yep, you can use hex, you can use RGB, you can use HSL. They've got some crazy, amazing stuff in there that will, I've been using D3 sort of on and off and experimenting for, 6 months to a year probably, and I had no idea I could do this until, like I said, I was researching this, reading an article that I actually have linked here, D3 Scales and Color by Jerome Cuquier, I believe, and was like, holy crap, you can do it with anything. Very much recommend reading that article and basically anything on his site. He's pretty amazing. Let's see, 11:35. So axes, I'm not going to really spend much time on this, but most charts you're going to want an axis to sort of give context. We've got basically the same scale that we had before. I hard-coded this one to 0 and 50. So I guess that's kind of worth noting. In the previous examples, I was just setting the domain based on our data, right? So it was going to create a scale based on whatever we had in our data set, which sometimes is useful. Other times, you just know that you want a 0 to 50 or 0 to 100 chart. In that case, you just manually set it in the domain, so 0 to 50, and then our range is still exactly the same. And then we've got d3.svg.axis, again, built in to D3, set the scale, pass in the scale that we created, orient it to the bottom, tell it how many ticks you want. So you could, by default, it'll try and guess how many ticks and labels it should create, or you can tell it exactly how many. And then the bottom part here, I won't go into a whole lot of detail, but basically we're appending a G element to our SVG, which is just a container for more graphics, setting the class to an axis class that sort of just defines the weight of the stroke, the font for the labels, that sort of thing. We do have to apply a transform to set it to the bottom. So I guess the orient bottom up there tells it to put the ticks and the labels on the bottom of the axis, and then this transform call actually tells it where to place it. And then you have to use a call method to sort of have it execute that on the axis itself. Not entirely important to go into the details of that because it's kind of just one of those things you go and look up once, get comfortable with, and move on. So transitions. Everything's cooler with animation, right? Putting aside the fact that you shouldn't have transitions just for transition's sake, they are often nice, can convey meaning. Really, that's the only time you should use it is when you can convey meaning. And what I mean by that, so the project that I've been working on for the last few years that I mentioned is visualizing education data. And so we have, we'll have a bubble chart that represents school districts. And when you double click on one, you're going to drill down and see the schools that are inside of that district. So what we do is you double click on a bubble, all the other bubbles fade back. That bubble sort of explodes into the school bubbles that make up that data, because we're trying to convey the relationship of the data that you're currently viewing to what you're going to view. Without spending any more time trying to convince you not to use gratuitous animation, I'm going to use some gratuitous animation. But so we've got basically our existing sort of structure where we've got the enter call, tell it to append a circle. In this case, I'm telling it to initially set the x and y to the width and the height of our chart. So everything's going to start off in the bottom right corner for absolutely no good reason. And the radius is going to be 0. So basically an invisible dot at the bottom right. All you have to do to add a transition to this chart is call transition. And the transition is going to act on whatever selection it's applied to. So in this case, we're applying it to the enter selection. You can do the same thing for the exit selection or the update selection. We're going to give it a delay of 1/4 of a second. We want the transition to last a 1/2 second. And then we're just going to use the same functions that we had before for the x and y to pass the data value through our scales and then set the radius attribute to 12. So what this gets you is a bunch of bubbles that animate in from the bottom right corner and sort of scale up while they're doing it. Again, not meaningful at all, just trying to sort of convey the process of implementing a transition. Going back to what I said before, where anytime you pass in a value, you can also pass in a function. In this case, instead of just telling the whole thing to delay for 1/4 of a second before it starts, I'm actually going to use the index of the data point to set the delay on each bubble depending on its index in the data. So, the very first data point is going to go immediately. The second one is going to have a delay of 100 milliseconds. Second one 200, and on and on. So what that ends up looking like is something that animates in, again, their delay is based on their index in the data. So you just kind of get a nice little, I don't know what you call that animation. Staggered delay, thank you. My vocabulary is suffering today. While we're being gratuitous, let's just go for it all and have those go in. So again, we're still using the staggered delay. Again, thank you. And in this case, we're animating the position, the size, and the color. And I'm going to actually show you the code for this one just real quick. Just because it's still amazing to me. I really, I had to be disciplined when I was putting together my presentation to not just, lose an hour playing with demos and, tweaking things and seeing what kind of cool crap I could come up with. But so all we have to do, again, you can see this is about 75 lines or so. I'm on line 10 here where I start, and then we're done. Well, okay, so it's 50 lines, 45 lines. But so I've got the data set, the width, the height, the padding, our normal, create an SVG, sort of bucket to work in, our X scale, our Y scale, just like we had before. This time for the color scale, it's another just built into D3. It basically has these sort of color palettes that you can just automatically generate. So in this case, I'm saying give me 10 color categories. There's like a category 20, and you can create your own color palettes. But in this case, just using the built-in, and then when we're working with the enter selection here, so everything that's going to get added needs to be appended. Its width and height, or its x and y are set to the width and height. The radius is 100. The opacity is 0. Here's my transition. It's still got the staggered delay start. Duration I slowed down just so it's a little easier to see. X and Y going through a scale, and then in this case, to do the color, I'm just setting the fill attribute and passing that through a color scale. So super, super easy for what you end up getting out of it. I don't know. I just like refreshing it over and over again and kind of playing with it. So further reading, there's a lot of information out there on D3. Scott Murray's D3 tutorial up here, a lot of this presentation is actually sort of adapted from his. He's got a very, very good sort of step-by-step, starting from the basics of using the div-based bar chart that I showed all the way through the SVG stuff. That was the tutorial that really sort of got me over the hump of like getting my head fully around D3. I had done tutorials here and there and sort of dug into different things, but that step-by-step tutorial is really kind of what got me over the hump. So if you're interested in getting into D3, I would highly recommend that. He's actually writing a book. He's basically like turning that tutorial series into a book and then expanding on it. So fully recommend that. And again, sticking with the sort of the academic aspect of this, he's also a professor at, I believe, UCSF, basically teaching data viz and stuff. So a lot of the people involved with this are doing it from the perspective of like, how do you actually create meaningful data visualizations and not just the flashy crap that I'm showing you today. Thinking with joins is a tutorial. I don't know if it's a tutorial or just sort of a wiki article by Mike Bostock that sort of goes over the enter and exit selections that I covered a little bit, but he obviously goes into more depth, and it's a very good one. Object constancy is another article by Mike that basically shows you how to make sure that D3 sort of always keeps the same element mapped to the same data point. When you're changing data sets, obviously you don't want this data point to represent Timmy's test scores and this one to represent Billy's, and then you do a transition and all of a sudden this one represents Billy's and this one's Timmy's. So, and it's really, the core concept of it is, of the way that D3 implements it is actually very simple. When you call the data method and pass in your data set, you basically just give it a function that it can use to identify each data point individually. So basically, it ends up usually being a function that returns like the ID property of the data object, and that just helps it. That allows it to, make sure that the same element always represents the same piece of data. Manipulating data like a boss with D3. That's by the same Jerome Cuquier guy. Has some really cool stuff in there. And basically just talking about sort of how to structure your data to work with D3 in the optimal way. Obviously, there's a million different ways that you could represent the same data set. They could be an array of objects, an array of sort of a multi-dimensional array, and he kind of goes over some of the things that you want to keep in mind, and he actually covers a lot of built-in D3 methods also that I wasn't aware of before I read it, that sort of allows you to manipulate your data using things that they've provided rather than having to brute force a lot of those things. Animations and Transitions is another article by him that does a lot more sort of step-by-step demos of how to create transitions, how to chain transitions, that sort of thing. And then Mike Bostock's site, so Mike, I didn't really go into much more detail about him at the beginning, but he was obviously at Stanford studying all this stuff. I don't know if he actually got his PhD or if he ended up leaving before he got it, but he then went to work for Square, the credit card processing company, doing sort of their back-end data visualizations for their management consoles, and has recently moved on to the New York Times. So I assume everybody in here has seen a lot of the data visualizations that the New York Times does on the web, which are, easily some of the best and most widely seen visualizations these days. I think they're using D3 for basically all of them, and he's now running a lot of those. So those are the links that you definitely want to check out if you're going to end up working with D3. And now, are there questions? Yep.
Yeah, does it have event handlers built in, or do you use JavaScript event handlers?
It does have a decent amount of event handlers built in. I was going to include some of that, but was worried I wouldn't have time to put them in. But basically, in those method chains where you're calling attribute, style, whatever, you can just they have an on method, and you just call on, click, on, mouse over, whatever, define a function, and then again, I believe you get, I know you still get the data point and the index in your handler function. You may get some event information too, but I'm not sure off the top of my head. But yeah, it's really easy to add sort of basic interactions like clicking and mousing over and those sorts of things. Yeah. It does, yeah. I don't know if they have anything built in for XML, but they have built-in methods for pulling in CSV files, TSV files, and then I don't know if they have, I think they do have a built-in JSON where you just point it to a URL, but I mean generally what I would do is, load my JSON on my own and pass the actual parsed object in there and then just operate on it that way. But I think they do have a built-in, like, here's my JSON file, here's my CSV file, and it'll parse it into objects for you. And probably should have shown that at some point, but if you're actually dealing with objects rather than just a flat array of numbers, which you'll probably never just deal with a flat array of numbers, rather than passing D into X scale, you would pass in like D.X position or D.Y position or whatever property on that, because D is going to be the actual object. Yep. It's all done by D3. You just yeah, basically once you create that X scale, when you call the X scale function and pass it in a data object, well, like I was saying, normally you would probably pass in a property of D, so it would be like D.X, and the X scale knows to take that value that you just passed in and sort of translate it to what it needs to. If you're talking about positioning, yeah. But I mean, like in the case of the color scale, it's going to return, basically a hex value or a color value. So it just depends on what kind of scale you're creating. Yeah. Yeah, you would just pass in D bracket 0, D bracket 1, whatever. Right. So, right, if your original data set was an array of, 2-element arrays, in here, if your data set was, 0, 0, 5, 5, 10, 10, you would pass in, D bracket 0 to the X scale and D bracket 1 to the Y scale, that sort of thing. Yep. At what? That's like the 3D sort of thing. Oh, okay. Yeah, I haven't looked into it, but I was looking at some other WebGL library and sort of fantasizing about what could happen if they were able to adapt D3 to work in WebGL rather than SVG, because I don't know how many people have looked into WebGL, and I have only to the extent that I've sort of played with demos, but the performance is mind-blowing. Like, the performance of this, to me, is really impressive, but I've seen WebGL demos where they're animating like 50,000 nodes on the screen completely smoothly, no stuttering. It's amazing. So I would love to see somebody create a bridge, that lets D3 act on WebGL. That would be, yeah. Okay. I think I saw that. Yeah. Yeah. Oh, okay. Oh, cool. Yeah. So if somebody here could go home and create a D3 to WebGL bridge, that I'd appreciate that. Is anybody else? Yeah. I've seen a couple of articles where they talk about combining Canvas and SVG. I don't know the details on it, but apparently, Canvas is better for some things and SVG is better for some things. And I have seen a couple of articles about sort of combining them and using one for, I guess maybe they were using SVG for sort of well, I don't know, maybe I'm getting that backwards, but they were using one of the two for sort of the overarching visualization itself, and then one for sort of, nodes within it. So you can combine them. Yep. Yeah, so the question was, I guess, about using sort of anonymous functions versus named functions and that sort of thing. Yeah, I mean, you very easily could, convert one of these functions that passes the value through xscale. You could easily create a named function for that and pass in the name if you wanted. They are very, I mean, as you can see, they're very big proponents of sort of the chaining syntax, which can get a little bit messy, but with a little bit of care, sort of your indentation style, you can keep it pretty well organized. I didn't do it on most of these slides because it's just a little bit hard to sort of show a large amount of code, but a lot of times what I've seen is like they'll do sort of the base chart setup, and then the enter call will either be outdented or indented another level, and then everything that acts on the enter selection will be sort of, indented a layer extra for what's under enter, and then sort of the same thing for exit. So you do sort of end up being able to partition it a little bit. Or you can pull it out into, I've also seen people create like, they get a reference to the selection, and then they create a variable that is like selection.enter, and then they've got a variable that is holding the enter selection, and they operate on that. And so that can sort of reduce the amount of indentation levels you have also. Yep. Only when I need to. Yeah, well, so if we actually look at the source, you'll see that, so in this case, the SVG property does come from D3, so we're doing D3's selection and getting a reference to that actual object. And then in this case, we're just acting on that object. So it does. Right. Right. Yeah, it's just chaining everything. And like I said, you can chain as little or as much as you like. You could probably create an entire visualization with a single semicolon at the end, but I don't know that I would recommend it. Yeah. Mm-hmm. The SVG, actually the SVG is just, well, so I guess it's not directly the tag itself. It's a D3 sort of reference to that tag. Yeah. Right. So when you call append SVG, D3 is kind of creating the element itself in the DOM and then giving you back a reference to sort of a wrapper for that element that then lets you call those methods on it. And I actually did want to show too, just to show the sort of the inspectability. So if you open up the web inspector here, you can see we've got our SVG tag here that was created by D3 with our width and our height set to it, our style. And then you can expand it and see that, there's your circles. You can inspect it the other way, just go directly out there. Select that circle. You've got your styles here. So if you want to add, I want this one to be red. So, and then you've modified it there. You can modify the values in the tags themselves. So now that one's red. So like I was saying initially, this can be very useful for when you're building your visualization. You're not exactly done yet. You want to go in and tweak some values and see, okay, actually this hex value would work better, or maybe you're using it to recognize that this data isn't exactly what you expected it to be, or maybe your scale didn't translate your data to the exact coordinate value that you expected it to. But it's very useful for going in and being able to sort of tweak the CSS and do a little bit of live editing sort of thing. Anybody else? Wow, look at that. Timing worked out perfectly. All right, well, hold on. Thank you.